In this video, we're just going to talk about how do I determine if the samples presented to me are independent or dependent. So again, first just starting with a refresher, is this first just focuses on how the samples are taken. So how the data was collected. Also, an important thing to keep in mind when trying to make this decision, we should always assume they are independent until we know otherwise. So what I have here is I have quite a few examples. I have 6 of them. What I would recommend doing, at least at some point, is to pause the video and try some of them on your own. You might watch like the first couple and get an explanation and then pause it and try the next few on your own, but I have 6 examples. So at some point it's going to be good for you to try them on your own, have a reason why you chose what you did, and then see if your answer was correct or not. Alright, so for my first example, we're comparing how 2 different movie reviewers rate certain movies. So for each movie, they rate a movie on a scale from 1 to 5 stars, with 5 being best. We took a sample of 120 movies that they have both rated and recorded how many stars that they gave the movie. Now, I may present this a little different. I like to draw pictures because I think sometimes that can help students. So I have reviewer 1 and reviewer 2. Those are sort of my 2 groups that I'm looking at here. So let's suppose that reviewer 1 watched the movie called The Prodigy and reviewed that movie. So does the fact that reviewer 1 of the ones that we sampled of them was The Prodigy, is there anything now that we have to sample here for reviewer 2 that goes with it? Well, the movies that we selected are the ones that they have both rated. So if reviewer 1 had rated The Prodigy, so did reviewer 2. So what this one then is going to be, this one is going to be dependent because they watched this and reviewed the same movies. Alright, looking at the next one here. The university has 2 new hires in their physics department. They're teaching the same course. So we want to see how they compare. They give all students in both of their classes the exact same final exam. We took a random sample of 40 students from each professor's class, and we recorded their grade they received on the final exam. So this time we're comparing then 2 professors. What we're technically sampling is the different students in their class. So suppose for Professor 1, one of the students that we sampled is Sally. Now, because I sampled Sally in Professor 1's class, is there a student that I must sample in Professor 2's class that is going to go with Sally? No, right? Because just because I sampled Sally doesn't tell me I have to sample a certain student inside Professor 2's class. So for this one, again, since we start assuming things are independent until we know otherwise, it's going to be independent. Because at least from what we know, we have no known reason to match the students. Now, a reason that some students may want to say that this one is dependent is because they were given all the same final exam. But keep in mind, all of the students in the class were given the same final. Right, so just because Sally took that final, who is her match in the other class that has to be sampled because of her? She doesn't have a match in the other course, at least not from what we know. So again, so assuming they are independent until we know otherwise, I have no reason why Sally is matched to a certain student in the other course. Okay, the next one. We're looking at the gender gap when it comes to salaries. So we wanted to see if this was true in the business field. So we took a random sample of 50 men and 50 women, and we got their starting salary in dollars. So my two groups here are going to be my men and my women. And so let's suppose that I sampled John as one of my men in business. So now when I go over to the women's group, is there someone I have to sample as a woman because I sampled John as a man? Nope, right? I mean, again, it's sort of like the one above. I don't have any reason to match a certain man to a certain woman, so it's going to be independent again. So we don't have any reason to match men and women. Again, if you haven't paused at some point yet, this is a good time to try it before we go to the next page. Right, our next example, we're looking at a marketing company that's launched some different products this year. They want to see how they're doing. So to test this, they record the amount of profit in thousands of dollars for the month, 2 months after launching the product, and then again at 8 months after launching the product. They do this with 25 products. So kind of our two groups, we have kind of like 2 months after and then 8 months after. And so let's suppose that we sampled some cell phone that they had at 2 months after. So because I sampled this cell phone at 2 months, is there anything we have to do at 8 months? Right, I have to sample that same cell phone. So what is this one going to be? It's going to be dependent because we sampled the same items both times. Okay, looking at E, we're looking at a beverage bottling company that they're launching 2 new sodas, which are called Mystery 1 and Mystery 2. They're comparing the sales of the products. So they're out on the market during the same 12-week period, and then we get the sales in millions each week. So my two groups here are my 2 sodas, Mystery 1 and Mystery 2. The thing about what I'm technically taking a sample of, I'm taking a sample of a week. Alright, so this is week 1. I mean, you could give it dates if you wanted to, so we'll just pretend it's the beginning of the year. So 1/1 through 1/7. So now for Mystery 2, is there anything I have to do because I sampled week 1 for Mystery 1? Right, I got to sample the exact same week because they were on the market during the same time. So it's that same weeks that makes this one dependent. All right, last example here. We're looking at multiple birth children and seeing if they have similar IQs. So we took a sample of 15 sets of twins and had each take an IQ test to see how similar they were in nature. For each twin, we scored and got their IQ from that test. So we're going to have like twin 1 and twin 2. So let's suppose that one of the twins we sampled is named Jan. Because I sampled Jan, is there anyone now that I have to sample that goes with Jan? Well, it has to be whoever her twin is. I might not know her name, but whoever her twin is, I have to sample. So for that reason, they are dependent because a set of twins goes together. All right, so here we don't have the exact same person that we're measuring, but they're a pair as I'm sampling them, right? Basically, I'm taking a sample of twin sets that I'm working with here. So hopefully those examples, that's helping explain a little bit better of how you decide if it's independent or dependent.